first.
Okay, so organic chem, guys, what makes organic chem its own thing? Like, why does it get its own name? Because organic chem is all about carbon-containing compounds, okay? Carbon-containing compounds behave very differently than all other compounds. And if you want to know the truth, this class that you are in, AP Chemistry, could really be called inorganic chem, because most of what we do in here is not dealing with carbon-containing compounds. So when you go on to college, you will see course titles like inorganic. If you see the term inorganic, you can interpret that to just basically mean like what you've learned in this course. Organic, very, very different. Okay? And what we're going to be dealing with are molecules called hydrocarbons, which, don't overanalyze it, guys. That word means exactly what it sounds like. What elements do you think are involved in a hydrocarbon? Hydrogen and carbon. Very good. Okay. And the first family of hydrocarbons that we're going to look at is a family called the alkane family. Okay? They're carbon chains. What makes them specifically part of the alkane family is that the chain of carbons, 2 carbons, 3, 4, 5, 50, however long, has all single bonds. Okay? Alkanes contain all single bonds. And there's a word that we've used before, okay, that we can describe alkanes. We would say these are saturated alkane or saturated hydrocarbons. Now, take your brains out of chemistry. Put your brain in your English class. Okay? If you came across the word saturated in like a poem or a short story, can you give me a synonym for the word saturated? Full, can't hold any more, okay? Well, it means the same thing in chemistry. These carbon chains are full, saturated with what? With hydrogens, okay? Essentially what it means is at every available location, there is a hydrogen. Remember, carbon will only bond to 4 things, okay? So a saturated hydrocarbon, all single bonds, loaded up with hydrogens. What's the opposite of saturated? Unsaturated. Okay? Unsaturated hydrocarbons are simply carbon chains where somewhere in the chain you'll see a double or a triple bond, or maybe more than one double or triple bond. Okay? And you hear these words, unsaturated, saturated, when we talk about nutrition, like saturated fat versus unsaturated fat. Well, if you guys will remember from chapters and chapters ago, we talked about how fats and oils and things like that are long carbon chains. Okay? What's health-wise better for you? Saturated fat or unsaturated fat? Unsaturated fat is better for you, okay? And here's why, right? Let's say this is representing a fat molecule. You've eaten it, it's now in your stomach. Your stomach is going to digest it. When your stomach digests a molecule, what does that really mean is happening to this molecule? Yeah, the bonds are being broken. Okay. Does breaking bonds require energy or release energy? Require. Okay. So your body has to do work. Your body has to actually expend energy to digest food. Now, which is going to require more energy to digest? An unsaturated fat or a saturated fat? Unsaturated. An unsaturated fat. Believe it or not, it is actually healthier for you if your body has to work harder to digest something, okay? Now, once all of these bonds are broken, all of the pieces are then going to go on to other biochemical reactions, which will then create energy. Do you remember from biology, ATP? Okay? Essentially, all of these things are going to go into creating ATP for your body, which is like the fuel of your body. Okay? But the point is, hydrocarbons, okay, things that you eat that are easy to break down are not as good for you. Saturated fat, sugars, carbohydrates. These are compounds that are relatively easy to break down, whereas things like molecules that you find in vegetables, proteins, they are more difficult to break down, and that's a good thing. That means you have a longer, more delayed release of energy, whereas sugar is so easily broken down that you eat it and you get an instant rush of energy, but then you crash, right? Okay? So I just wanted you all to be aware of that. Okay. Here's a word you need to know, isomerism. Okay? Isomers. I want you to look at these two formulas, okay? Please notice that these formulas are exactly the same. 4 carbons, 10 hydrogens. And yet, these are two different molecules. Butane, isobutane. Now, what makes them different? Look at the picture, okay? These black pieces are representing the carbon atoms, okay? What's making them different? Okay, how they're arranged, how they're bonded together. This has the 4 carbons just joined essentially in a chain, whereas here they're bonded in like a T shape. And honestly, guys, the more and more you go on in science, especially chemistry, the more you will realize everything comes down to shape. How things react ultimately is determined by how they are shaped. These are shaped differently. They will react differently. They are different molecules. However, because they have the same formula, we call these isomers. Same formula, different arrangement. Okay, and isomers will react differently. So the main thing that we're going to get into today, guys, is learning how to draw alkanes and how to name them. And the first thing you need to know about naming them, you got to know your Greek prefixes. Okay? These prefixes, ladies and gentlemen, are tied to how many carbons are in the main chain of this hydrocarbon. Okay? And 5 carbons and greater are these Greek prefixes that you probably know. Pent, hex, hept, oct, non, dec. The first 4 are not Greek. I'm not sure if they're Latin. I don't know where they come from. But you just have to know them. Like 1 carbon has the prefix meth. And yeah, I know what you're all thinking. Like methamphetamine? Yeah, like methamphetamine. Okay? Methamphetamine is called methamphetamine, crystal meth, because it's a 1 carbon compound. Okay? Meth, eth, prop, but. And if you're like my chemistry teacher in high school, she made us chant these first 4 prefixes because they're not the logical Greek prefixes. So, you know, we basically had to put on like robes with hoods and hold candles and meth, eth, prop, but, like we were some religious cult or something. Okay? Meth, eth, prop, but, or you can just be quieter about it and just remember monkeys eat peeled bananas. Okay, whatever works for you. Okay, but guys, some of these should be familiar to you. Like if you have a gas grill out in your back patio or whatever and you grill steaks, you have likely a propane tank attached to it. Okay. What's the gas that comes out of our jets to feed our Bunsen burners? Methane. Okay. if you have access, you know, if you've used a cigarette lighter, which I'm sure you've never used, okay, those are usually butane, right? Octane is a additive used in a lot of race cars use it as an additive to their gasoline. But these are all fuels, very flammable. Okay, and it's all tied to the number of carbons. Okay, so let's talk about how to name these things. Okay, the first thing that you have to do, if I give you a molecule and I say, name this hydrocarbon, the first thing you need to do is find or count how many carbons are in the longest consecutive chain. All right, let me say that again, because that's not always so easy to just see immediately. How many carbons are in the longest consecutive chain? Okay, 1, 2, 3, 4, 5, 6. Okay, prefix for 6 is hex, hexane. That's an easy one, but sometimes finding that longest chain isn't always so obvious. Sometimes the longest chain isn't in a straight line. For example, what if I draw something like this? Okay. Your job is to find the longest consecutive chain of carbons. You guys tell me, is that the longest chain? No. No, it's not. Here is the longest chain. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. What would the prefix be? Non. So this would be, I'll even draw a little box around it. My main chain, which is not always in a straight, straight line. Here would be my main chain. So the main chain is nonane, okay? Not no name, nonane. Okay, so your first job is always to find the longest consecutive chain of carbons. I personally find it really helpful to draw a box around that main chain. Now, what are these extra things that are attached to the main chain? Well, they have a fancy name. Attachments to the main chain are called alkyl substituents. Okay? They're just things attached onto your main chain. Okay? And if you had, let's see, I'll draw this up on the board, or actually I can just do it up here. To this 6-carbon chain, let's say that's my main chain, I have a carbon attached right there. Okay? Here's the main chain. This is attached to it. This is an alkyl substituent. Now, this substituent has 1 carbon. What's the prefix for 1 carbon? Meth. Okay? Well, I'm not going to call this methane hexane. If it's a substituent, it gets this YL ending. I would call this methyl hexane. Okay? If I had 2 carbons attached, I would call it ethyl. Methyl, ethyl, propyl, butyl, pentyl, hexyl, etc. Okay? So that's how you name substituents. Now, do you have to identify where that substituent is attached? Yes, you do. So let's talk about that. Okay? Let's say you have this situation. Nice simple one. We'll get more complex in a minute, don't you worry. All right, how many carbons are in the longest chain? 6. Okay, so what's my base chain? My main chain? Hexane. Okay. And what do we call a 1 carbon? Methyl. We call it methyl. Okay. Now here's the thing. When you've got substituents, you need to number your main chain of carbons, because in the name, we have to indicate which carbon is this methyl group attached to. All right, and this is how we're going to number it. And I know a question that will be on your mind, and I will answer it right this minute. Do you always number from left to right? No, you don't. How do you know whether to number from left to right or right to left? Here's how you know. You want to number in whatever direction is going to put that substituent on the lowest number carbon you can get. If I numbered from right to left, guys, which carbon would this be on? It would be on carbon number 4. Well, having it on 3 is better. So I'm going to, in this particular situation, I'm going to number it from left to right. So here would be the name of this compound. It would be 3-methyl hexane. All one word, no spaces. Okay? So that tells me on carbon number 3, there's a methyl group attached to a hexane chain. Okay? Let's make this more complex, shall we? I know you were dying to make it more complex. Okay? What if I do that? Is hexane still the longest chain? Okay. So this is called a methyl group. What's this called? It's also a methyl group. Okay, exactly. If there's 2 of the same kind, I'm not going to say methyl-methyl, I say dimethyl. What if there were 3 of them? Trimethyl. What if there were 4 of them? Tetramethyl. Okay. You were close, quattro.
I didn't say that.
I think both ones know it.
I know, it's okay. So this is how this guy would be named. Are you ready? It would be named 2,3 dimethyl hexane. Okay. Is my numbering system still okay? Is it still good that I should number from? Okay. All right. All right, let's change it. Let's change it again. Let's do this. Because we might have to change the numbering. We may not. Let's just see. Let's do. I'm going to change this. Add another carbon up top. And I'm going to put a carbon down here. Okay? Is 6 still the longest chain? Yeah. And in this case, guys, it actually doesn't matter if you make this the longest chain or if you go up here, it's still the same. It doesn't matter. Let's just make life easy and make this the main chain. Okay? So hexane. What do we call this substituent? Okay, it's a methyl group. How about the one on the top? That's an ethyl group. Okay. Let's decide how to number this chain. Should I number from left to right or right to left? Why? Yeah, numbering from right to left is going to give me collectively lower numbers. So 1, 2, 3, 4. Okay. All right, we're almost ready to name this sucker. Last thing to think about. Tell me, guys, what comes first in the alphabet? E or F? Very good. Okay. Now, that did not, knowing which comes first in the alphabet, that did not have any impact on how I number my carbons, but it is going to impact what order I name things in. So here we go. Ready? 4-ethyl. I'm going to put that first because it alphabetically is first. 2-methyl hexane. All one word. Anytime you have a number and a letter together, you put a dash, letter to letter, you just push them together. 4-ethyl 2-methylhexane. Okay. I'm going to give you some practice with this, but let me just say something. I want you to, starting today, I want you to start looking at the active ingredients, at things you come in contact with, medications, cleaning supplies. You know, you get bored in the shower, start reading the back of your shampoo bottle. You're going to see compounds written like this, and now you will know what these numbers and prefixes mean. Okay? So let's do some practice. Here's how we're going to practice. This says, name and draw the 5 isomers of the alkane C6H14. I am telling you that there are 5 ways to arrange 6 carbons and 14 hydrogens. And there are only 5 ways to do it. Now, I'm going to help get you started. What do you think is the simplest way to arrange 6 carbons? Straight chain. Okay, great. So that would just look like this. And it's fine with me, guys, if just for today, if you want to just focus on drawing just the carbon backbone and not worry about drawing in all the hydrogens, that's okay with me for today, because we're just learning this. But if you drew them in, you would count 14 hydrogens. And how would you name this molecule right here? Hexane. Congratulations. That is isomer number 1. There are 4 more. Here is my suggestion to you on how to get started. We've just drawn a 6-carbon chain. My suggestion to you is now start drawing a 5-carbon main chain and use that 6th carbon as a substituent. Okay, attach it somewhere. Now, let me save you some heartache, because I know, I can guarantee that about half the people in this room are about to draw this. Are you ready? 5-carbon chain is what I said, right? 1, 2, 3, 4, 5. Some people are going to draw this. I mean, it's 5 carbons, and I took that 6th carbon and just attached it, right? What's wrong with this? It's still just 6 carbons in a row. This is hexane. This is not a new isomer. This is the same thing as that. Just because I bent it doesn't matter. That doesn't change it. Okay? So think about what could you do with this carbon so that it's not just 6 in a row. We're going to take plenty of time. If you want to draw them first and then go back and name them later, fine. Okay? I'll walk around and offer assistance. Okay, there they are. So you may not believe me, but anything else that you draw, any other arrangement besides these that, you know, has 6 carbons, 14 hydrogens, I promise you, is actually one of these other ones. Sometimes it's really tricky to see where your longest chain is, but I guarantee you, I didn't draw it up here, but with the first one, the simplest one, which was just 6 carbons in a row, hexane, and these 4, these are the only ways you can arrange 6 carbons and 14 hydrogens, I promise you. There's no other way to arrange it without ending up with one of these same ones. Okay? And as I said, for today, if drawing in all of the hydrogens makes you uncomfortable, for today, I'm okay with you not doing that. Eventually, when we do actually take a test on this material, you would need to draw in all the hydrogens, as annoying as that is. Okay? And I know this seems silly, like why do you have to do 2, 2, but you just, that's how the system works. Now, guys, one thing that I did see as I was walking around, and I'm actually really glad that a few people did this. For this one in particular, I saw a couple of people like putting a single bond right there, like creating shapes, okay? Now, it's not that molecules with carbon, squares like that, it's not that they don't exist. They do. We're actually going to talk about it in just a second. But if you were to put a single bond right there, your carbon count might be okay, but the number of hydrogens would not be 14 anymore. And thus, it would not be an isomer, it'd be a different molecule. Okay? But I'm actually really glad that people drew those shapes because they do exist. Right? They are called cycloalkanes or cyclic alkanes. Okay? Tell me, guys, what shape has 3 sides?
Triangle.
Good, okay. It's not a trick question. Woo!
Hexagon?
No.
Square. It's a circle. It's a circle.
Okay. Such a thing does exist. Now, a 3-carbon cyclic alkane would be incredibly unstable and you probably wouldn't find it, but just for educational purposes, if I had a 3-carbon shape, and I would still have 2 hydrogens coming off of each carbon, 3 carbons. Meth-prop is the prefix. Propane, because they're single bonds. Remember, alkanes are all single bonds. But it's not just propane, it's in a shape, so we call it cyclopropane. What's a 4-sided figure, ladies and gentlemen?
Square.
Okay, rectangle. Rhombus. No. Okay. It's one of my favorite words in the English language, parallelogram. I just like the sound of it. Parallelogram. Okay? So, 4 carbons joined in a shape, not just butane, but cyclobutane. Okay? Do you guys think that I could have some substituents attached to these shapes?
Yes.
Oh, you bet. Why not? Let's do it. Okay. So let's do this one together. Okay, get used to seeing this, guys. Organic chemists, because they have to do a lot of drawing, they get very lazy. And instead of drawing 6 carbons, because at every corner you are to understand that there is a carbon at every corner, instead of drawing out a hexagon of carbons, they will just draw this shape. Okay? So if you're given a drawing and you're supposed to name it, if you see a shape, your question isn't how many carbons are in my longest chain. Your question to yourself is how many carbons are in the main shape. And what's the answer here? 6. What's the prefix for 6? Hex. It's a single line at every place, so that implies a single bond. So ane, hexane, and it's in a shape, so cyclohexane. I'm going to write the name sort of working from the back. Cyclohexane. Okay, now, what do we call things that are attached to the main shape or main chain? Substituents. Okay, if these hydrogens are bothering you, just ignore them. What do you call a 2-carbon substituent? Ethyl. It's an ethyl group. Okay. How about a 3-carbon? Propyl. Now, don't write that down. This one is actually called, because you wouldn't know this, so I'm just going to tell you. This is called isopropyl, and I'll explain why. Okay. Many of you, I'm sure, have heard that word before, like isopropyl alcohol, rubbing alcohol. Okay. Here's why this is isopropyl and not propyl. Let me just show you what propyl would look like if it were a substituent. What would be like that. Look, what's the difference? They both have 3 carbons. They would have the same number of hydrogens. What's the difference?
The carbons are bonded to one another.
Well, even though this doesn't look like it, these 3 carbons are bonded to one another. Okay, it would look like this. Hydrogen, 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 hydrogen. What's the difference? This is joined like that. It's where is it joined onto the main shape? This guy is joined at the end. This is joined with the central carbon. Do you guys know what the prefix iso means? Like an isosceles triangle? Same or equal. This is symmetrical. It's the same on both sides. So this is called isopropyl. Okay. Let me erase this because it's not propyl. Okay. So we've got an ethyl group, an isopropyl group. Just like we do with our chains, we've got to number the corners of our shape. Where do you think I should, which corner do you think I should make as corner number 1? Yeah, let's make it the ethyl one. Okay. Now, why did you choose ethyl instead of the isopropyl? It kind of matters. Technically, in this case, it does. Doesn't E come before I in the alphabet? So if I can make that carbon number 1, I will. Now guys, should I number this shape counterclockwise or clockwise?
Clockwise.
Why clockwise? Yeah, we want a lower number. Okay, so let's name this guy, and I'm going to try to space this out as perfectly as I can. So this would be 1 ethyl, 2 isopropyl cyclohexane, all one word. 1 ethyl, 2 isopropyl cyclohexane. Don't you feel smart saying these things? I feel smart. I not act smart, but I feel smart. Okay. All right, so you guys do the rest. You're going to name number 2, and then you're going to draw these 3 other ones. Okay, again, when you've got a shape, you don't have to draw out carbon, 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 carbon. You can just draw a shape like that. Enjoy drawing a 7-sided figure. You enjoy that. Okay, try these. Okay, guys, let me put the answers up, and I want to show you some options as to how you draw these things out. Okay, so check your answers in a minute, but I just want you to look at something, okay? You can, if you wish, draw your substituents out like this, and this goes for not just cyclic alkanes, but any of your drawings in organic. You can draw it out bond by bond, hydrogen, 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 okay? Or you can draw them out like this, still showing some of the bonds, but kind of collapsing it down a little bit. Or you don't have to show any bonds at all and just draw it like this. I know this doesn't seem like a, quote, drawing, writing it like this, but you can. If writing it like this or this makes you uncomfortable because you're worried, like, am I going to get the correct number of hydrogens? Then just draw it out. It's totally up to you. Any of these would be acceptable. Okay. What are your questions? Yes? Ken?
In drawings like this, if we draw bonds going to nowhere, are we allowed to assume that there are hydrogens? When you have just bonds going on
if I
like
was
that?
doing this, no. I would need to actually write in H, 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 H. Yeah. Okay? So, to give you just a little final practice with this, okay? I'm going to give you the name of something, and I want you to draw it. It's actually not a cyclic molecule at all. Okay? Here's what I want you to draw. Shouldn't be too difficult. All right. Just to make sure we've got this. Okay. 3,5-dimethyl-4-ethylnonane. And this time, I want all hydrogens represented, whether that's actually drawing them in one at a time, or like some of the options I showed you. Go.
Is there only one answer for this?
When you draw things, not really, because like me personally, I'm going to start at the end, and I'm going to draw the 9 carbons out straight. You could draw 9 carbons in a zigzag shape if you want to. Yeah. As long as the methyls and the ethyl are joined to the correct number carbons, the shape that you draw them doesn't matter.
So we're drawing like.
It's not a cyclo. Just me personally, when I'm given a name and I'm asked to draw it, I work backwards. I will draw out the main chain first and then kind of work my way back. But you can do it however you want. Your drawing may not look exactly like mine, and that's okay. As long as you have a 9-carbon main chain and your substituents are joined onto the correct number carbons. I chose to number from left to right, but you didn't have to, and you're good. This is usually how I like to draw mine. I like to do kind of a hybrid of drawing some of the bonds, but not all of the hydrogens, all of the bonds with the hydrogens. That's what I like to do, but it's totally up to you how you do it. We good? Okay. Isn't this kind of fun? I mean, it's definitely different. All right, so we will stop here.